Hey there, fellow van builders. Welcome back to my channel. I'm the van teacher, Jason Sickle. In today's video, I'll be covering everything you need to know for designing and installing your van's electrical charging system. The first part of this video will cover using solar to charge your batteries. The second part will cover DC to DC alternator charging. And the third part of this video will cover shore power charging. Also, throughout this video, whenever you see a product you might be interested in, I have provided links to every component used in the description below. For detailed information on those products, be sure to check out their links. Now let's get right to it. I have divided solar charging into 5 parts. Part 1. Sizing your solar array and mounting your solar panels. Part 2. Wiring your panels together and routing the wires into your van. Part 3. Choosing and connecting to a charge controller. Part 4. Connecting your charge controller to your batteries. And Part 5. Testing and system monitoring. Let's get right to it. The first step in designing a solar charging system is to determine the size of your solar array. When making this decision, you'll want to take into consideration the available space for solar panels, the size of your battery bank, and the other methods of battery charging you plan to install. Perhaps most importantly, you'll want to estimate the amount of energy consumed by the loads you will be using. When I decided to purchase 2 solar panels, part of the decision was simply based on the fact that 2 panels fit nicely on my roof. Knowing that I would only have 2 panels, I began looking at my options for how many watts I could obtain. Solar panels are typically available in 100 to 200 watt sizes, and you generally pay for more wattage. I knew that I wanted to get as much wattage as I could out of the 2 panels, so I ended up purchasing a set of 2 175 watt panels. I did calculate my energy use, and I also factored in that I would be installing alternator charging as well as shore power charging. Once you have decided on the number of solar panels, the next step is to determine where and how to mount them to your van. After carefully measuring my panels and roof space, I decided to build a simple, low-profile roof rack using 80/20 aluminum and Ram Promaster roof rack adapters. The panels easily mounted to the 80/20, and the 80/20 easily mounted to my roof. I placed the panels close to the front of the van so that I would have room in the back for a roof deck and vent fan. In my previous van, the panels were more centered so that I could install a front and rear vent fan. If I change my mind about the mounting location, the 80/20 aluminum rack allows the panels to slide back and forth along the length of the roof. Check out my roof rack installation video for more details on that. The next topic you need to address is how to connect your panels together and how to route the wires into your van. Let's start with connecting your panels together. You have 3 options: series, parallel, or series parallel. First, the definition of each one. In a series connection, the positive wires are connected to the negative. Output voltages add together and the output current remains the same. In a parallel connection, all of the positive wires are connected together and all of the negative wires are connected together. Output currents add together and output voltages stay the same. In a series parallel connection, strings of series connected panels are wired together in parallel. This type of connection may be used if your charge controller's voltage limit would be exceeded if everything was wired in series. Usually, this type of connection would be used in larger systems like 4 to 8 or even more panels. The type of connection you choose depends mainly on how you want to set up your system. Wiring in series is a popular choice for small van and RV applications for several reasons. First, because the voltage adds together, you can more easily charge your 12-volt batteries in low light and low levels of solar output. This is because typical 12-volt batteries need over 14 volts to begin charging, and a 100-watt panel would need to output at least 75% of its capacity to provide that voltage. When you add additional panels in series, adding their voltage allows them to operate at 50% or even 25% of their capacity and still charge your battery bank. A second advantage of series wiring is that since amperage doesn't increase, smaller gauge wire can be used. This makes wiring easier and less expensive. Another advantage is that no additional connectors are needed when connecting the positive wire to the negative. On the other hand, series connections do not perform well in partial shade. This may be an important consideration if your installation location is shaded by other equipment on your roof or if you frequently park in shaded locations. Series wiring also requires MPPT charge controllers, which are not as budget-friendly as PWM controllers, which are used in parallel configurations. Once you have decided how to connect your panels together, it's time to figure out how to bring the wires into your van. Note that wires are now live, so proceed with caution. You may want to cover your panels with cardboard until you have installed a solar disconnect, or you can complete your installation at night. The most direct route for running your wires will likely be through the roof and straight down to your charge controller. You may also be able to route the wires through an existing opening to avoid drilling through the roof. Keep in mind, however, the longer the wire, the more voltage drop you will have, and the less efficient your charging system will be. If you want to maximize efficiency, use the shortest route. When going through your roof, take several precautions to prevent leaks and protect your wires. Use a combiner box or wire ports to accomplish this, and use plenty of roof lap sealant to keep water out. Also be sure to paint over the drilled holes with rust-proof paint and insert a rubber grommet into the opening to prevent wire damage. Now that you have the wires inside the van, you must install a solar disconnect to shut down power from your solar array, not only because it's nice to be able to do that, but it's also a code requirement for PV systems. Be sure to use a dual-pole disconnect like this one, and not a positive-only disconnect in order to satisfy this code requirement. Wiring in your disconnect is as simple as connecting the positive wires to the positive terminals and the negative to the negative on both sides of the switch. Leave the disconnect in the off position until you have completed and tested your installation. After the wires leave the disconnect, route them to your charge controller. As for wire size, if you are connecting your panels in series, the current will be relatively low and 6 to 12 gauge wire will be appropriate. I used 10 gauge wire for the solar extension cables that run from the panels to the solar disconnect, and 6 gauge wire from the solar disconnect to the charge controller. When selecting the proper charge controller, calculate the voltage and current you will have coming from your solar panels. The simplest way to do this will be to enter the panel's information into a charge controller calculator such as this one. The calculator will then help you select the proper controller. Alternatively, you can determine this yourself by following the charge controller's manufacturer recommendations. For my 350-watt system, with a total open circuit voltage of 54 volts at the lowest possible operating temperature, has a maximum output of 25 amps. I chose to use the Victron Smart Solar MPPT 100/30 since the max voltage of my system is well under 100 volts and the current is under 30 amps. Connecting to the controller is rather straightforward as it only has positive and negative inputs from the panels, and positive and negative outputs to the battery. It also has an equipment ground that connects to the negative battery bus bar. When connecting the positive and negative 6-gauge wire from the solar panel disconnect to the charge controller, I used ferrules to terminate the wires and inserted them into the rising clamp and tightened it down. Now that the charge controller is connected to the solar panels, you can then proceed to connect it to your battery bank. Be sure to disconnect your batteries before proceeding. The charge controller will have an equipment ground that needs to be connected to the negative bus bar on your battery bank. I used 1/4 inch lugs to connect the 6-gauge equipment ground wire on the controller side and a 5/16 inch lug to connect it to the links distributor. The 6-gauge output wires from the controller heading to the links distributor are terminated with ferrules on the controller side and 5/16 inch lugs at the links distributor. Fuse size at the links distributor can be calculated by multiplying the amperage of the controller by 1.2, which equals 36 amps. Using 6-gauge wire at this connection results in a recommended fuse size between 40 and 60 amps. I installed a 60 amp fuse as seen here. The links distributor is then connected to the batteries using 4/0 wire with a 200 amp fuse in line with the positive cable as close to the batteries as possible. Both the positive and negative cables between the links and the batteries need to be the same length, including the length of the monitoring shunt on the negative cable and the shutoff switch on the positive. I measured this from the negative terminal on battery 2 to the link's negative terminal, and from the positive terminal on battery 1 to the link's positive terminal. Now that all connections have been made, test your system visually by following the wires to make sure positives are connected to positives and negatives are connected to negatives. To test your system with a voltmeter, first confirm that both the battery disconnect and solar disconnect are switched off. Then turn on the battery switch and use a voltmeter to check for proper connections between the battery and the charge controller. Test at the positive and negative output terminals on the solar charge controller. You should get a reading of between 11 to 14.6 volts. Next, turn on the solar disconnect and check the voltage at the charge controller inputs. This should be the output voltage from your panels. Finally, check your monitoring system to see that everything is operating correctly. Once your system passes these tests, you can leave it switched on. Now sit back and enjoy your work. Congratulations on building a safe, reliable, and efficient solar power charging system. Next up is DC to DC alternator charging. I have divided this part of the video into 4 sections. The equipment, wires, fuses, and parts you will need, how to connect to your starter battery, how to select and connect to your DC to DC charge controller, and how to connect the charge controller to your battery bank. Let's get right to it. The alternator in your van converts mechanical energy to electrical energy, which is used to maintain your starter battery and provide the power needed to run the electronics in your van. You can tap into this system by connecting to your starter battery and running the wire to a charge controller connected to your van's battery bank. The charge controller's job is to regulate the voltage going to your batteries, protect the alternator from overload, and to keep your starter battery voltage from getting too low during the charging process. The first step in installing this system is to locate a suitable location to connect to your van's starter battery. You can connect directly to the battery's positive and negative terminals, or you can connect to an upfitter power source that leads back to the battery. In the Ram Promaster, the upfitter connection can be found in the B pillar on the passenger side. I connected directly to the battery because it is closer to the house battery and there is an empty terminal on the terminal bus bar. As you can see here, I simply added a 60 amp fuse and a bolt that gives me a place to attach the fuse and wire lug. The bolt needs to have a square head, and I used a 1/2 inch 5/16 inch bolt that I had to cut shorter to fit under the terminal cover. This is an ideal spot for the fuse as it is as close to the battery as possible. An inline fuse would be needed if you do not fuse your connection at the battery. When determining the fuse and wire size for the wire feeding the controller, Victron recommends a 60 amp fuse and a 6 gauge wire for runs longer than 6 feet. The negative cable is also 6 gauge and also connects directly to the negative terminal bus bar. I then routed these wires under the flooring, under the seat, and along the driver's side wall. I protected the wires anywhere they might come into contact with metal edges and used zip ties to help keep them in place. For my system, I used the Victron Orion Isolated 12-12-30 controller. This controller is for 12-volt systems and can charge at a rate of up to 30 amps. Because the Promaster alternator is rated at 180 amps, this controller will at most only pull 30 amps from the alternator. For those of you who need more power, Victron just released a new DC to DC charger called the Orion XS 12-12-50. Not only does it charge at 50 amps, it has much improved operating efficiency and improved monitoring and control features. I used ferrules to connect the positive and negative 6 gauge wires from the starter battery to the input side of the charge controller. The 6 gauge output wires from the controller heading to the Lynx distributor are terminated with ferrules on the controller side and 5/16 inch lugs at the Lynx distributor. Fuse size at the Lynx distributor can be calculated by multiplying the amperage of the controller by 1.2, which equals 36 amps. Using 6 gauge wire at this connection results in a recommended fuse size between 40 and 60 amps. I chose to use a 60 amp fuse as seen here. The Lynx distributor is then connected to the batteries using 4/0 wire with a 200 amp fuse in line with the positive cable as close to the batteries as possible. Both the positive and negative cables between the Lynx and the batteries need to be the same length, including the length of the monitoring shunt on the negative cable and the shutoff switch on the positive. I measured this length from the negative terminal on battery 2 to the Lynx negative terminal, and from the positive terminal on battery 1 to the Lynx positive terminal. Now that all connections have been made, test your system visually by following the wires to make sure positives are connected to positives and negatives are connected to the negatives. To test your system with a voltmeter, first turn on the battery switch and use a voltmeter to check for proper connections between the battery and the charge controller. Test at the positive and negative output terminals on the DC to DC charge controller. You should get a reading of between 11 to 14.6 volts. Next, turn on the engine and check the voltage at the charge controller inputs. This should be the output voltage from your alternator. Finally, check your monitoring system to see that everything is operating correctly. Follow the controller's directions to properly set cutoff voltages and charging rates. Now, sit back and enjoy your work. Congratulations on installing a safe, reliable, and efficient DC to DC alternator charging system. Next up, how to install a simple shore power inlet for charging your battery system. This video will cover how to install the inlet to the outside of your van and how to connect it to a battery charger or other AC loads inside your van. Note that this video only covers 15 amp inlets wired to a run of a few outlets, and not 30 amp inlets wired to inverter chargers. Although most of the installation is similar, their purpose and use is a bit different. So let's get right to it. First, select a suitable location for installing your inlet. You will want to take into consideration the part of your van that you want to drill a hole through and where you want to have the wiring enter your van. Most inlets are either installed on the side closest to your battery bank or on the back bumper area. You can even locate the inlet underneath your van and nearly out of sight. My preference is to install the inlet on the back of the van just below the taillight. My reason is simple and practical. First, I didn't want to drill a large hole through the exterior side metal. The trim panel plastic could be more easily replaced if I make a mistake or decide for some reason to remove the inlet. And second, if I forget to unplug, the cord will pull itself straight out rather than to the side as I drive away. If you do choose to drill through the side metal, be sure to carefully measure the hole size, collect those metal shavings, and paint the exposed metal with rust-proof paint. If you are installing the inlet on the Ram Promaster taillight trim panel, you have several options on how to bring the wire into your van. The easiest is to slip the wire through the pressure relief vent opening and right into the rear pillar. The vent is covered by a rubber flap, so you may want to cover the opening with metal screen or wire mesh to help keep bugs and critters out. Alternatively, you can drill a small hole into the rear pillar behind the taillight, use a rubber grommet to protect the wire, and seal around the wire with spray foam, silicone, or lap sealant. Now that the inlet is installed, it's time to wire it into your system. You will want to use 10 gauge, 3 conductor, stranded marine grade wire. The question of whether to use stranded marine wire versus solid residential wire for AC wiring is often debated. But if electrical codes specifically addressed AC wiring in a van or RV, it would likely specify stranded wire and outlets designed to accept such wire. Rather than giving you my personal opinions on this topic, I will leave it as a best practice recommendation to use marine grade stranded wire properly terminated to be used with automotive AC outlets. Whatever wire you choose, be sure to add protection wherever the wire passes over sharp edges, avoid bending the wire at tight angles, and secure the wire with plenty of zip ties to reduce movement. To begin wiring the inlet to your system, first connect the 3 colored wires to the back of the inlet. Black is the hot wire, white is neutral, and green is ground. Next, route the wire to your first AC outlet. The first outlet in your run should be a GFCI outlet. If you plug your van into a GFCI protected outlet, this protection carries into your van. Since most outdoor outlets are on GFCI protected circuits, you are likely also protected by the outlet you plug into. My first outlet is in the garage area of the van, and I use it for an AC battery charger. At the end of this video, I will go over the items you plug into your system and how to ensure you are not overloading it. When wiring your first outlet, you will use a parallel connection so that you can extend the circuit to a second outlet. This means you will connect the incoming hot wire, black, to the right side brass screw, the incoming neutral wire, white, to the left side silver screw, and create a pigtail for the green ground wire and connect it to the ground screw. The wire heading out to your second outlet will be wired to the outgoing brass hot screw, outgoing silver neutral screw, and connected to the green ground pigtail. You can then connect your second outlet the same way as the first and continue the run to as many outlets as needed. The other important consideration will be the length and gauge of your outdoor rated extension cord. This cord will run from the outdoor outlet you've plugged into to the inlet on your van. Make sure it is rated to carry the amperage of the circuit and use the shortest extension cord you can. Basically, use common sense here and don't overload the circuit the same way you should not overload circuits in your home, garage, or workshop. In my 3-outlet shore power system, I have a Victron smart battery charger that draws 7.5 amps plugged into outlet number 1, our TV plugged into outlet number 2, and the refrigerator plugged into outlet number 3. The total amperage, if all of the devices are on at the same time, is less than 9 amps. Occasionally, I may plug in a 1000 watt electric heater, but I make sure that nothing else is plugged in at the same time, as it alone can draw over 9 amps. If you would like additional information on van electrical systems, check out my camper van electrical overview video, or for more detailed tutorials, check out my videos on installing solar power, DC to DC chargers, quick electrical tips, and a complete guide to DC circuit wiring. If you would like to know how much my electrical system cost, or any other budget-related items, check out my video on how much our 2023 Ram Promaster cost to build. Also, check out the links in the description below for more information on any of the items mentioned in this video. If you found this video helpful, hit the like button, subscribe for more content, and share your thoughts and experiences in the comments below.